Okay, Assalamualaikum and good afternoon. Okay, so let's start the class. Can you hear me?
Yes, hello.
Yes, can, Doctor.
Okay, that's good. So we start our class with the subtopic from last week. So because of the last week we don't have class, then that's why we discuss this week lah. Okay, hopefully you're already done with the exercise that I asked you to do. Okay, so that we can you will be more understand when we go through later. Okay. Wait, Okay, so we start with the 3.3 hypothesis testing for the difference between two population means. So we have independent sample and also dependent sample. Okay, so similar idea as a confidence interval. Okay, I don't think that we need to discuss more about that. Okay, so you should know how to identify, okay, whether we have the independent sample or whether we have the dependent sample. So it is about the data set itself lah. Okay. So first, independent sample. Okay, so independent sample, we have two different data from two different population. So population is the subject from where we get the data. Okay. So that's why for the independent sample, the parameter that we use is a mu1 minus mu2. Okay. So based on the question, we decide the hypothesis letter. It is a mu1 minus mu2, or we can write as a mu2 minus mu1. Okay. But in general, in this form, okay, but you have to know, okay. Based on the question, the one refer to what and the two here refer to what, because the rest of the analysis, when you calculate for the test statistic, you must be follow your hypothesis, which one minus which one, okay. So we still have in general two type of the statistical hypothesis. Okay, we have the two tail here and then we have the one tail here, right tail and left tail. Okay, the difference it is on your alpha. Okay, so two tail means that we divide by 2 the alpha, and one tail is just alpha. Okay, it is for your critical value lah. Okay, for the traditional approach, the type of hypothesis is very important when we do the decision letter. Okay, so most of the time when we have two population, your mu naught equal to 0 most of the time. We don't have the population mean in that question, then we assume that mu naught equal to 0. Okay, most of the time, but sometimes we do have some value for the mu naught. Okay, so in terms of the formula, how to choose the formula similar as what we did for the confidence interval. Okay, so we still have 5 different formula. Okay, for this independent sample, we use a Z test and also t-test as our distribution here. Okay, so how do we choose the formula? We have 3 conditions that we need to identify. So the first one is population variance known or unknown. Okay. The second one, if unknown, the second one is a equality of the population variances, whether they are equal to each other or whether they are unequal to each other. Okay. After that, it is your sample size. So either both greater than equal to the 30 or both less than 30. So these are 3 conditions that we need to identify, okay, in order to choose which formula that we need to use. Okay. You can interrupt me anytime if you have any questions. Okay, we go to the exercise 3.3.1. Okay, I ask you to do the number 3 here. Okay. So before we go to the solving, first step is to extract the information. Okay, what is the variable in this study? Anyone? Variable? What is the variable in this study? Anyone?
Effective using music.
Effectiveness of using music. Okay. Effectiveness of using music here is a purpose of why we conduct this study. Okay. So to evaluate the effectiveness of using music, what data that we collect? Okay, in order to reflect to the effectiveness of using music. So the data, the raw data that we collect, it is your variable. Okay, ingat variable is the data that been collected. Okay, so in this study, what kind of data that been collected to reflect the effectiveness of using music during the working hour? That's your variable. So what kind of data that we collect here? Productivity level. Okay, productivity level. So the easiest way to identify the variable, it is based on the calculated value. Okay, the value given in that question, for example, mean, the standard deviation, or the proportion, or the number of success, they are from what? Mean of what? Standard deviation of what? Proportion of what? That what is your variable. Okay, because that what is the data that been collected. Of course, we calculate value from the data. So variable is your data. Okay, so in this case, we have productivity level as a variable. Okay, so here we have two different situations. Okay, the first one when music off and the second one when the music on. So you can write here, you have music off and then you have music on. Okay, so extract what kind of information that we have. When the music was turned on, the mean and standard deviation of the productivity level for 45 employees were found to be 5.2 and 2.4. So 45 here, why is that?
And
Okay, and then we have 5.2 and 2.4. So 5.2 X bar. Okay, 2.4
Yes.
and standard deviation. So we have these three information, 45, 5.2 and 2.4. Okay, and then for the music on, the mean and standard deviation of the productivity level for the 40 employees were 4.8 and 1.2. So 40 here and 4.8
X.
S bar, 1.2
S.
S. So we have N, 40, we have S bar, we have the S. 4.8 and 1.2. Okay, and then what do we have? Do the employees perform better at work with the music playing? This is what we call the purpose of this study lah. Okay, we need to conclude whether the employees perform better at work with the music playing or not. Okay, what can we conclude at the 0.05 level of significance if both population variances are the same? So 0.05 here, that's your
Alpha.
alpha. Both population variances are the same. How do we write that statement? Both population variances are the same. How do we write this statement?
Sigma 1 equal to sigma 2.
Sigma 1 equal to sigma 2. Or you can write here sigma square of equal to the sigma square 1. Okay. So based on this information here, then you should get the idea that it is independent sample lah, because of we have this condition. Okay, we have this condition in this study, so it is independent sample. Okay, that's how what we call it, based on the information, we know what we are dealing with lah. Okay, and then we're done with all the informations, then we go to the hypothesis. So the first step is to formulate the hypothesis. So hypothesis coming from the purpose of this question. So the purpose is to conclude whether the employees perform better or not at the work with the music playing. So what we can conclude, when we have what we can conclude, or we need to discuss whether that statement is true or not. Okay, most of the time we have to perform a test. Okay, so what test that we need to perform depends on the question. Okay, so here we have basically two populations. So it is something from chapter 3 lah. Okay, when we have more than two, then it is method from chapter 4 later. Okay. So, okay, your hypothesis from this statement, okay, do the employees perform better at work with the music playing? So before we formulate, the first thing that you have to identify is a parameter that we need to use. Okay, so parameter that we need to use in that hypothesis. So first we know that we have quantitative data, productivity level, we calculate mean, we calculate standard deviation from that. So it is a quantitative data. Okay, so the most suitable parameter to use is mu and also sigma. Okay, definitely it is not the pi, because pi is for qualitative data. Okay, and then so we have either mu and also sigma. Okay, so we need to answer this, do the employee perform better? And then we chart the story here lah. Okay, whether is there any special condition relate to the perform better here? Special condition that for example, special condition that relate to the probability. Okay, if you have that kind of special condition, for example, employee perform better if the variance, if we have smaller variance, for example. So you have that kind of condition, the special condition. So automatically it is a sigma. Okay. When there is no special condition like that, then we go to the most common one, which is mu. Okay. If you need to use sigma, it will be a condition that relate to the verbability. Then you can use the sigma. Okay. If not, then we go to the most common one that we use for the quantitative data, which is mu. Okay. So similar, if you have the raw data, you have your own experiment, you need to perform the hypothesis testing. So usually we go to the mean first. Okay, and then after that, if you decide probability is more effectiveness to use, then we go to the probability lah as the parameter. Okay, so here there is no special condition that relate to the probability, then we go to the mu. Okay, so what we call that, that's how we determine the parameter for hypothesis. Okay, you need to understand that. Okay, and then so we know that it is a mu. Okay, after that we need to decide which one is a first population. So in this case, which one is the first population? Music off or music on?
On.
Music
On.
on. Why music on?
On. Sebab dia mention perform better at work with music playing.
With the music playing, because of the keyword here, music playing. So it must be on first. Okay, so on. And then off. And then we need to decide on the sign. Okay, on the sign. So perform better. What kind of sign that's suitable for this term? Perform better. Greater than. Why it is greater than in this case? Last time we discussed perform better is not necessary greater than. It depends on something. Why is that? In this case, it is correct. It is greater than. Why it is greater than? Because of the productivity level, because of your variable. Okay, so if we change the variable here, we collect another data. Okay, for example, the most simple one, defective product. Okay, so if we have defective product as our variable, then perform better means less than. Okay, the defective must be decreased, then they are perform better. Okay, so it is not always perform better greater than. But in this case, you are lucky lah. Even though if you don't understand what we call why it is greater than, but you are lucky if you write greater than. Okay, but sometimes we do have less than for the perform better. So that's why it is important to understand why we have this kind of sign, why we have this kind that sign, this sign, and so on. Okay, you have to understand why. Okay, so variable is very important. It will influence your sign here. Okay, so in this case, greater than because of productivity level. Okay, oh sorry. Sekejap ya, macam mana pula nak buat ni? Okay. Okay, so greater than, do we have any value for the mu naught? Do you have any value for the mu naught?
No.
No. So it is
0.
So we have this hypothesis H0 or H1?
H1.
H1. Because we have not equal sign. So H0 opposite to that lah. Okay. So mu on minus mu off less than equal to 0. Where is your claim?
H1.
H1. Okay, when we have mu not equal to 0, you can write your hypothesis in this form lah. Mu on also correct. Okay. When we have mu not equal to 0, then we can write our hypothesis in this form. So also correct lah, it's up to you. Okay, then the step 2 is to choose the task statistic. Okay, the first condition, do we have sigma in our question?
No.
No. So sigma on, sigma of unknown. Okay. And then equality of the population variances. We have equal or unequal.
Equal.
Equal. So based on the condition given in your question here. So on equal to the off. What about your n? Greater than 30?
Greater than 30.
Greater than 30. So n on and off greater and equal to 30. So we use formula with z-test and also SP. So for the z-test here, the S bar, which one minus which one? For the S bar? Which one minus which one? On minus off. So the z-test cannot be contradict to your hypothesis. We have to follow the hypothesis. So hypothesis we already decide on first, then when we calculate for the test statistic, it has to be on first. You have done right. So what is your z-test?
-7. Okay.
Negative.
Negative 0.9530.
Okay, so negative 0.9530 or 31. And May, you get negative 0.7744. How many of you get similar as this one? Okay, so far we have 3. Yeah, 4. So I think May, you have to check your answer. Maybe something wrong somewhere. Because the rest, okay, the rest of your friend got similar as this one. Okay, so you can check your answer after this. Okay, and then step 3. So the type of hypothesis, the type of your statistical hypothesis, 1 tail or 2 tail?
One tail.
1 tail, and it is right tail. So alpha 0.05, then you have 1.6.
1.6449.
And then step 4 is to make your decision. Okay, if you sketch this figure, then it is encouraged to plot various z-test in this figure. So less than critical value or upper greater than critical value? Your
Less
z-test
than.
should be less than, so somewhere here because we have negative. So decision dia apa?
Do not reject.
Do not reject. Can we write accept Hashna? Cannot. Tak boleh mathematically accept Hashna is incorrect. It is wrong. Okay, because the reason why we do not reject the Hashna here because of lack of the evidence. It is not really we accept the Hashna here. Okay. So what happened to the claim? Do we support the claim here? Do not reject Hashna. What happened to the claim? We reject or we support? Conclusion, we have to discuss what happened to the claim, isn't it? Okay, so here do not reject Hashna. So what happened to the claim? We reject the claim, okay? So do not reject the hash null means that we support the hash null here, the statement of hash null. So we reject hash 1. So because of claim at hash 1, then we also reject the claim. So one of the conclusion that you can write at alpha 0.05, there is enough evidence to reject the claim that employee perform better at work with music playing. Any question? Or you can write there is not enough evidence to support the claim. Also correct, no? There is not enough evidence to support. Also correct. Okay. So you as a manager, should we turn on the music? Turn off, should be turn off. So no lah. Okay, if we have a question after that, for example, as a manager, should you turn off the music or not? So you have to answer based on what is your decision here lah. But here, because of here, we do not reject hash null, we reject the claim. So means that the manager should not turn off the music lah. Okay. Any questions so far? Okay. So we go to the dependent sample. Okay. So dependent sample, it is we have two different set of data from same population. So means that from same subject. Okay. So how do we analyze? We combine those two data. Okay. By calculate the data different. So the rest of the analysis, it is based on the data different. So that's why the notation or the parameter that we have is a mu d. So d represent data different. So now we have mu d. So that's why the formula that we have similar to the single population mean. The difference is you have notation d. So d is for data different. So here should be 3 different formula lah. Okay. So similar as a single mean. Okay, you will have mu d known or mu d unknown. Okay, and then we have the n less than 30 or n greater than 30 to choose the formula. Okay, so how do we formulate the hypothesis for the mu d? Okay, it is if for me, okay, I will start from I will regard that question as an independent. So we formulate the hypothesis like independent first, and then we convert into dependent sample. Okay. Let's say that we back to the exercise just now. In your opinion, how do we modify this study so that we have dependent sample? Let's see whether you really understand or not the dependent. Okay, we have this question, this study. Okay, how do we modify this study so that we have dependent sample? What we need to change here? Anyone? Size of sample. Okay. What about size of sample? Same employees. Okay, the keyword is same employees. Okay, that's the what we call the thing that we change in order to make this study to be a dependent sample. We change the employee. Okay, so we use similar employee. We collect the data from similar employee. One of the data when the music off, and then another data it is when the music on. Okay, And then when we have dependent sample, because of the same employee, the data come from the same employee, then the number of samples should be same to each other lah. Okay, so first data, second data, number of data should be similar to each other. If you have different, then it is totally independent sample. Okay. Okay. Exercise this one. Okay. So how do I mean the analysis here is similar as a single mean. Okay. What is the variable? The number one. What is your variable? Workers hour. Weekly losses of the worker hours due to accident. Okay, that's the complete one. Okay, weekly losses of the worker hours due to accident. This is your variable. In 10 industrial plant for before and after installation. So means that the data before and the data after from similar 10 industrial plant. So that's why it is dependent sample. Okay, so what you have here is a sample data, so only from 10 industrial plants. Okay, so anything that you calculate from this data, the data different letter, it produce statistic. Okay, so by assuming the data are approximately normally distributed, test the hypothesis at 0.05 level of significance, either the safety program is effective or not. Okay, so this is what we call the purpose why we conduct this experiment. So this is your hypothesis. Okay, so when you have the dependent sample, do not do not jump to the data different yet. Okay, do not go to calculate the data different yet. Okay, because the data different must be based on your hypothesis. Based on the hypothesis, we know which one minus which one. Okay, so we go to the hypothesis. Okay, so as I said, when we formulate the hypothesis, it is better to regard first this experiment as an independent. So we formulate as an independent first and then we convert into mu D. Okay, so the hypothesis here must be menjawab balik yang ini lah. Okay, safety program is effective or not. Okay. So how do we know in this experiment the safety program is effective? How do we know? How do we know the safety program is effective? Less than. Okay, A less than B. Okay. Betul lah tu. Okay. So the safety program is effective if the data after installation should be less than the data before installation, because the safety program here supposed to reduce the weekly losses of the worker hours due to accident. So basically supposed to reduce the number of accident lah. Okay, that effect to the workers hour. Okay, so if the safety program is effective, then after installation, the data after installation should be less than the data for the before the installation. So what you can write here, we have mu A less than mu B. But before that, is there any mu naught in this question? Ada mu naught tak? Tak ada. Okay, so there is no mu naught. So that's why we can write mu A less than mu B. Okay, so we formulate as an independent first and then we convert into dependent. Okay, so what we do, okay, after this we will have mu A minus mu B, which is less than 0. So mu A minus mu B, that's your mu D. Okay, so that's how we formulate the hypothesis. Okay, so mu D less than 0, you have H0 or H1?
H1.
H1. Okay, so H0 opposite to that, mu D greater than equal to 0 and claim will be at H1. Okay, for the dependent sample, we have to notify. The D here is what? Okay, so where mu D is mu A minus B. So based on this, we know the data different must be after minus before. Okay, we have to follow the hypothesis. Okay, so do not jump to the data different yet. You have to formulate your hypothesis, and based on the hypothesis, we know which one minus which one. Okay. Okay. Okay, for the dependent case, sometimes we can have more than one hypothesis. Okay, and then you can choose which one that you want to use. Okay, which one that you want to use. Okay, is it correct if we write mu B greater than mu A? Is it correct if we write this one? The safety program is effective or not if we write mu B greater than mu A? It is effective. Also correct. Okay, Neoli, do you want to ask me any question because you raise your hand? No, okay. Okay, so if we write mu B greater than mu A, also correct. Okay, also correct. Okay, the safety program still effective if the data before greater than data after. So you will have mu B minus mu A greater than equal to 0. So this is your mu D. Okay, so mu D greater than 0, it is H1, then H0, mu D less than equal to 0. Okay, but for the second hypothesis here, okay, your mu D is a mu B minus A. So the rest of the calculation, it must be based on B minus A. Okay, so the difference between these two hypotheses, it will be on your standard deviation. Standard deviation similar because cannot be negative value. Okay, you will have different on S bar D. Okay, one value you get positive and another one you get negative. A similar value, the different on the sign. So the second step, the formula that you use. Okay, one of the hypothesis negative and another one is positive. But the step 4 and 5, when we come to the decision and conclusion, they must be similar to each other. Okay, doesn't matter which hypothesis that you use, okay, you must get similar decision and also conclusion because we use similar data set, so similar problem. Okay, so it is up to you lah. Okay, you nak pakai first hypothesis or the second hypothesis. Both will be accepted, but do not write both lah. Okay, it will be confusing later. Okay, any questions so far? I think the rest you can do it by your own, that one. Any question? Okay. Okay, we go to the Sekejap Okay. Okay, we go to the next one. We have 3.4. Okay, population proportion. Okay, so the parameter that we use here, we have the pi. Okay, So similar idea as a confidence interval, we use Z distribution. Okay, so here you will have the Z task. Okay, so we have the pi here. And for the right hand side, we have the pi note. So be noted that this pi note is between 0 to the 1 only. Okay, if you have the percentage, make sure to convert first. We cannot write like pi equal to 45%, tak boleh. Okay, it must be pi equal to 0.45. Okay, dia mesti what we call fulfill this characteristic lah. Okay, pi note from 0 to 1. Okay. Okay. And then, okay, so similar as a confidence interval, we have single formula for this case. Okay, so we have the Z test here. Okay, and similar formula to find the P. Okay, X divided by N, but what we call, be careful that sometimes we do have P in that question, already P, not the apps. Okay, already P in that question, so use as it is. Okay, my experience previously, I think in final test, forget that one. Okay, we give, in that question, we give P. So what the student do, they convert into X and then they divide by N and then they get the P. And the problem is the P that they got different from what we give to you. Okay, so it is wrong lah. Okay, our answer, it will be based on the P that we give in the question, not the P that you get. Okay, because that's the difference between, I mean, that's how we differentiate the student, whether you really understand or not. The value given here is P or you or what. Okay, if the value given already P, use as it is. Do not convert to the X and then divide by N and then get another P. Even though you have just a big difference. For example, that the P that we give 0.4, for example. But after you convert to the X, you divide by N, you get 0.45. It is incorrect. Okay, we do not consider that one. So you will lose some mark lah. Okay, so if it is already P, use as it is. Okay, do not bother to use the formula and then find another P. No. Okay, if you really have the X in that question, then it is yes, you have to divide by the N and then get your P. Okay. Okay, we discussed this subtopic in the exercise 3.5. Okay. So here we have two population proportion. Okay, so we have pi1 minus pi2. So similar when we do the independent sample. Okay, you have to decide later in that question which one it should be the first population and which one should be the second population. Okay. So still we use the Z task. Okay, so we have two different test statistics here. How to choose which one that we need to use, it is based on the pi note. Okay, the first case pi note equal to 0 and the second case is a pi note not equal to 0. Okay, so pi note equal to 0, the first case here you have the PP, full sample proportion. Okay, so this is how we calculate the full sample proportion. Okay, we go to the exercise. Okay, the number 2 here. Okay, so it is clear that you have proportion. No doubt it is a proportion. So you are dealing with the pi as a parameter. Okay. Okay, a sample of 400. First, what is your variable? What is your variable?
Manufacture.
Manufacture. Again, what is your variable?
Difference between the population proportion.
That's the what we call parameter.
Parameter, sorry.
What is your variable? The data that we collect based on what? Hmm?
2 year of manufacture.
Years of manufacture. No, we tak collect yang tu. Kita collect apa? Number of owner who report their car. It is number of car that need major repair within 2 years. That's your variable. That's the data that we collect. Okay, number of car that need major repair. Okay, that's the what we call the number, the success characteristic. So most of the time, the success characteristic is your variable lah. Okay, so a sample of 400 of the car model 1 is contact and a sample of 500. So 400 and 500 here, they are what? Apa dia? They are
Number of sample.
number of sample, the N. Okay. The number of owner for the model 1 and model 2 who report that their car that need major repair within the first 2 years are 53 and 78. So 53 and 78
X.
X. Okay, let's say that we change to the 53%, 78%. What are they?
P.
P. Okay, so that's how we define, that's how we know, because what we call it is a common it is based on the common sense. How do we know the value given is a P or the value given is a X? Okay, the X, the characteristic must be whole number, discrete number. Okay, if you have probability of something, you have the percentage of something, then it is P, not the X. Okay, it is P, not the X. Okay. So the A question, it is a confident interval. You can do it by your own. The B, determine whether the population proportion. So it is clear that we have proportion as our parameter of the car from model 1 that need major repair is less than 0.5. Okay, so it is only for the model 1, then it is single proportion. Okay, so less than 0.25, so you have pi 1 less than 0.25. H0 or H1? H1. Okay, so H0 opposite to that, pi 1 greater and equal to the 0.25. Okay, so claim at H1. Okay, so for this proportion, it is not really crucial. Okay, as long as you know, oh, that's a proportion, then the rest should be easy because of we have single formula to represent that one. Okay, we go to the C. Or you have any question about the B? If not, I proceed to the C. I have something to discuss about the C here. Okay, we go to the C. Test the consumer association hypothesis at 1% significant level. So this is what the purpose here. Okay, the purpose is to test the consumer association. So that's your hypothesis. Okay, and then back to the story here. What does the consumer association say? Okay, so consumer association wants to determine whether there is a difference between the population proportion of the two leading car manufacturers that need major repair. So how the hypothesis? First, do we have pi note here? Population pi? No, so pi note equal to 0. Okay, so you can write. So different, it is not equal. So we get the sign. And then we need to decide. We know already the pi, We know already, we know the parameter which is the pi, and then we have the sign, and then we need to decide which one is the first population. Which one is the first population? Need repair? Both need repair, right? Model 1. Okay. So in this question, it is a general one of two leading car manufacturer that need major repair. Okay, so general question. So it's up to you. You can do model 1 as a first population or model 2 as a first population. Okay, so to be easy, we just make model 1 as a first population. So you will have pi 1 not equal to the pi 2. H0 or H1? It is H1. Okay. Step 2. So which case that we need to use? Case 1 or case 2 for the formula, for the test statistic? Case 1 or case 2? For the test statistic, we need to use the case 1 or case 2? Case 1, because of pi not equal to 0. Okay, so since we have pi not equal to 0, then it is case 1. Okay, so you need to calculate the full sample proportion. So P1, so as I mentioned, test statistic, we have to follow the hypothesis. P2, okay. If you have done, what is the answer? Negative 0.9932. Okay, step 3. And the rest of you get similar answer, 0.9932? Yes, okay. Okay, step 3 is to find the critical value. So the type of hypothesis. The type of hypothesis. Two-tail or one-tail? Two-tail. What happened to the alpha? Divide by 2. So we have Z test, then it will be Z distribution. So alpha is 1%, divide by 2, 0.005. So 2.5758. So the lower critical value negative. Okay, so when we have two-tail case, it is compulsory to state both critical value, the lower critical value and also the upper critical value. Compulsory to state. Okay, so your Z test and then step 4 decision. Okay, your Z test negative 0.9932, which is in between. Betul? In between critical values, so somewhere here. So when you write the comparison, it is compulsory to state both sides. Okay, so means that negative less than the Z test and then Z test less than positive 1. Okay, compulsory to state. state, I mean, if you just state one side, salah If you do like this, for example, or you just write it is wrong. Okay, because when the Z test or the test statistic in between for the comparison, we have to state both sides. Okay, so if you did a mistake here, okay, let's say that you write either one from here, then I will refer to your picture here. If you sketch the picture lah. Okay, so if you sketch, make sure that you plot where is your Z test. So if you do a mistake here, we refer to this figure. So that's what we call the beauty of this figure lah. Okay, it will help you. Okay, because you kena ingat kalau kat sini salah, sini you buat salah, sini salah, automatically decision salah, automatically conclusion salah. So you will lose 3 marks because of that. Okay, got it? So, okay. Macam mana buat untuk test? Okay. So decision is do not reject. What happened to the claim? Do we support the claim? Do we support the claim? We support or reject? Not support. We reject the claim lah. Okay. So at alpha 0.01, there is enough evidence to reject. Okay, reject the claim that, so you have everything here. Reject the claim that there is a difference between the population proportion of the two leading car manufacturer that need major repair. Okay. Any questions so far? No. Okay. We go to the next one. Okay, so test a population variance and standard deviation by using chi-square test. Okay, so now we have the verbality as our parameter. When we say verbality, then it is correct if we write sigma square or sigma as a hypothesis. Okay, because sigma and sigma square both are about verbality. So for the hypothesis, you can you can choose whether you want to write as a variance or whether you want to write as a standard deviation. Both will be accepted lah. Okay. Okay, for the chi-square here, okay, definitely the sigma node here must be some value lah. If not, it will be undefined for your chi-square test. Okay, so we use the chi-square test, similar idea as a confidence interval. Okay, so the crucial part is your critical value because chi-square it is positive distribution. Okay, so positive distribution means that when we sketch the figure, it starts from 0. So doesn't matter, even though you have the left tail or you have the two tail, the lower critical value, it is positive value. Okay, so that's why lower critical value and upper critical value here, we have different value, different probability value. Okay, one of the reason because it is positive distribution. Okay, dia tak sama macam Z and T lah. Okay, Z and T, they are symmetric distribution. So they have the positive side and they have the negative side. Okay. So usually the mistake, usually students do mistake at the critical value lah, especially for the left tail and also lower critical value for the case two tail. Okay, they use the negative one. Okay, so bear in mind chi-square it is positive distribution. Okay, that's why we have different critical value for the lower and upper critical value. Okay. Okay, we go to the number 3 here. What is the variable? What is the variable? Ruler height. Okay, ruler height. Okay, the height for a sample of the 10 rulers. So this is a sample data. Anything that you calculate again will produce statistic. Can we stop the process at 0.1 significant level? Okay, so we need to answer this. So can we stop? The only way to answer is by perform the test. Okay, so we have the hypothesis testing here. Okay, stop the process. If the variance of the ruler height is not equal to the 2, the process will stop immediately. So it is clear here you have the variance. So automatically the parameter is a sigma squared. So we cannot use the mu. Okay. So variance, okay, because the condition that relate to this process is a variance. So automatically parameter is a sigma squared. Okay. So sigma square is not equal to the 2 cm. So it just sigma square not equal to the 2 cm. H0 or H1? It is H1. Okay, H0 opposite to that. Okay. Is it correct if you write this one? Betul tak? Is it correct? Yes, also correct. Okay, so you can choose actually whether you want to write as a sigma or whether you want to write as a sigma square. But if you are given variance, then use as it is, use the variance. If you are given standard deviation, then use as a standard deviation, use a sigma. Okay, to avoid any mistake lah, because when you convert into sigma, the right hand side also must be sigma naught. Okay, here. Okay, before this is sigma naught square. Okay, so when you write as a sigma, the right hand side must be convert into sigma naught. So the mistake might be on the sigma naught lah. Okay, maybe you forget to convert. So to be safe, you just use the condition given in that question. If the variance, then variance. If the standard deviation, then standard deviation. Okay. The rest I think should be easy because of we have single formula. Okay, we still have similar stuff. Okay, the difference is on the crucial part is on the critical value lah. Okay, especially for the lower critical value. Any question on this? You have done right. So any question on the number 3 here? No? Okay. Okay. So if no, we proceed to the next one. Okay, the last one for this week lah. Okay, so the last one we have ratio of two population variances. Okay, so we have sigma 1 square divided by sigma 2 square. Okay, so the only formula here is a f test equal to s1 square divided by s2 square. Okay, so f test here similar, f distribution similar as a chi-square. They are positive distribution. Okay, positive distribution. Okay, so for the hypothesis, other than we write the hypothesis in this term, we can write in the form of ratio. Okay, for example, okay, so first you can write in this form. Or we can write in the form of ratio. Okay, when we write in the form of the ratio, automatically the right hand side is 1. Okay, tak boleh 0. If 0, then 0 times with the sigma square here will be 0 lah. Okay, so right hand side automatically 1. So in general, pi node square always 1. Pi pula dah. Sigma node square always 1 for the ratio. Okay, always 1. Is it correct if we write in this form? Boleh ke? Yang biru ni boleh? Lagi? Boleh ke tak? Okay, one of your friends said yes. Yes juga. Lagi? Yes juga. I said no lah. We cannot write this hypothesis in this form because it is not the different. Okay, when we have two population variance, it is ratio. Okay, so this one cannot be right. We cannot write as a different. Okay, because when we have two population variance, it is ratio of variances, not the difference of variances. So that's why we cannot write in this form. So there is only two forms that you can write, first in this one and another one in the form of ratio. Okay, definitely not this one. Okay, if mu and pi, yes, you can write in this form because for the mu and pi, we do have different. Okay, but for this one, it is only ratio. Okay, so F distribution similar as chi-square, it is positive distribution, so it start from 0. Let's say that we have two tail here, then the upper critical value here, it is F alpha over 2, nu 1, nu 2. So different from what we have in confident interval. Confident interval, we need nu 2 first and then nu 1. Okay, but for the hypothesis, we need the nu 1 and nu 2. There is a theory behind that lah. Kenapa confident interval, it must be nu 2 first and then nu 1. And why hypothesis testing, it must be nu 1 and nu 2. Okay. So for the lower critical value here, we need F1 minus alpha over 2 and nu 1 and nu 2. Okay, as we know, this value is not in our statistical table. Then that's why we use the formula as what we did for the confident interval. So it is 1 over F alpha over 2 and then nu 1, nu 2. Because we need nu 1, nu 2 and here will be nu 2 and nu 1. Okay. Any question on that? Okay. Okay, we go to the exercise. Okay. Okay, the number 3 here. What is the variable? What is the variable? Time taken. Okay, so the variable is a time taken to assemble one unit of the product on each type of machine. Okay, so the question A. So you have only how many data here? 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 data from each machine. So it is a sample data. Okay, just 8 data. So at 10% significant level, test the difference in variability between the type of machine. So it is clear that we have keyword here, variability. So variability, the parameter related to that, it will be either sigma square or sigma. Both are correct lah. Okay, you can use sigma square or sigma. Different in variability. So how do we write this hypothesis? Macam mana? Different in variability between the two types of machine. How do we write this hypothesis? We already know here the parameter is a sigma square or sigma. Different means that not equal. So what we have here, sigma A square not equal to the sigma B square. So between two type of machine is up to you. You can write A first and then B, or you can write B first and then A. Okay, so you have this hypothesis. Okay, and then you can proceed lah, calculate the atas. Okay, so it is SA square divided by SB square. Okay, and then make your step 3 critical value and then division. Okay, conclusion. Okay. So what I want to highlight here, what we call the relationship between the quotient A and B, how they are related to each other. Okay. So B, any question on A? Any question on A? Okay. Which machine should be installed by the company to assemble its product? Test the hypothesis at 10% significant level and use the assumption of condition of variance equal or unequal based on your answer in A. So which machine should be installed? So we go back to the story here. The company will install machine B if the mean time taken to assemble a unit of a product is less than the mean time taken by machine A. So how is this hypothesis? Anyone? It is B minus A. So parameter? What is the parameter for this hypothesis? Mu. Okay. So mu minus A less than 0. So or you can write mu A because of mu not equal to 0. So sorry, mu A. Apa tadi? Mu B. Mu B less than mu A. So hash1, hash0, mu B greater than equal to the mu A. So claim at hash1. Okay. That's the hypothesis for the question B. And then step 2 is to choose the test statistic. So based on this hypothesis, we know that it is independent sample. the case of independent sample. So we need to choose the formula. What is the first condition to choose the formula for the independent sample? Just now we discussed. Apa dia? The first condition is B. Apa yang B-nya? The first condition to choose the formula for the, yes, for the B. Formula for B here. The first condition,
Sigma known or unknown.
sigma known or unknown. So in this case, known or unknown? Unknown.
Unknown.
Okay. So first condition, it is known or unknown. Okay. So sigma A and sigma B are unknown in this condition. In this case. The second condition, apa dia?
Equal or unequal.
Equality of the population variance. So whether we have equal or whether we have not equal. So in this case, equal, how do we know this condition? Is it stated in our question? It is from A. So the second condition here depends on your decision in A. Okay, let's say that decision on. Okay, let's say that the decision is reject H null. So reject H null, which one kita pakai? Reject H null means that which one that we choose, that we support, that we use, not equal. Okay, if you do not reject H null, then we use the equal one. That's how B related to A, because the second condition to choose the formula for the B depends on your answer in A. Okay, which one that you support, whether not equal or equal. Okay, that's how related to each other lah. Okay, and the third condition, that's your N. Okay, any question on that? Do you understand how they are related to each other? Okay. Apa nak cakap lupa. Okay. So, in order for us to use the answer in A for the B, one thing that you have to make sure is the alpha used here. Okay, the alpha used in B must be similar to the A so that we can use the answer from A. Okay, because they are related to each other. Let's say that we change the alpha for the B. Let's say that we need 5%. So automatically you have to test another ratio. You have to test another ratio of two population variance by using alpha equal to 5%. Okay, so the important condition here that you have to make sure is a similarity of the alpha. Alpha must be similar for the question A and question B. Okay, so that we can use the answer from A. Okay, so this one kita panggil dia guided question lah. Okay, we guide you. First, you have to test the difference. After that, we go to the independent. Some question you have to know by your own that you need to perform two different hypotheses in that. Okay, because of independent here, okay, we need to test first on the probability because we need that condition. Okay, any question? I think the rest you can read by your own. Okay, any question that you want to ask? Other than when you will get your test, still in process. Boleh? A or mu A. Okay. Okay, if in this case, kalau if you want to write A first, we need to modify lah. Okay, tak boleh like that. Tak boleh pakai less than ni. Because the less than here, because of it mentioned B first and then A. So if you want to mention A first, then it should be mu A greater and equal to the mu B. Okay, because the less than here, it is what we call applicable if mission B first and then mission A. So if you want to use A first and then B, then you have to modify like this. Okay, so this sign only if we mention B first and then A. Okay, so if you want to mention A first, then we have to modify. Okay, so because of here less than, then if A first, it should be greater and equal, opposite to that. Can we do ratio? Yes, you can. Because the A question, it is general. Okay, between the two type of machines. So you can do B first and then A. So for the F task, okay, if you decide here is a B, here is a A, B and A, then here should be as B squared divided by as A squared. Okay, so as I mentioned before, the test statistic tak boleh, cannot be contradict to the hypothesis. You have to follow your hypothesis. Which one first and which one later. Okay, any more question? Okay, so kalau there's no more question, I think that's all for today. For your information, in our teaching plan, it should be quiz 3 next week. But you just prepare yourself. I will inform later whether it will be next week or not. Okay, so far I missed that one. Okay, I'm not decide yet about the quiz 3. Okay, so you just prepare yourself. Saya pun tak ingat dah apa dia punya subtopic. Should be what Sekejap So the quiz 3 should be 3.3. Okay, means that independent sample and also dependent sample both. Okay, so I will inform later whether it will be next week or not. You just prepare yourself. If next week, then it will be on Tuesday like what we do for quiz 2 before. Okay. Any more questions? Ada? Okay, then that's all for today. Thank you. Okay, thank you class. That's all for today. See you next week, insyaAllah. Thank you.
Thank you, madam.
Yeah, quiz 3 only 3.3. 3.3 means the independent and also dependent both lah. Okay.